Andrew Morgan. I work for a company called 6.6, and I'm the head of data science and engineering over there. And I'm supposed to be here with Dan Smith, but we had a production issue yesterday, so he's running off doing some stuff. I want to talk today about a kind of graph that no one's really talking about, but it exists like all over the place, and it's a really important use case for graph databases in general, but I think specifically for Grakn because of the things that it brings. So I want to talk today a little bit about introducing this problem, and then I want to explore the problem. I want to talk about the big idea, and then I want to talk to you a little bit about some of the learnings that we had of this and the use cases that we have. Explained well, what we learned from them was what we actually learned that we needed to register a lot of objects in our organizations and use metadata to manage them. So I want to open up with an anecdote to kind of really explain the problem. So not that long in my past, I was hired to be the director of a large engineering team of about 50 guys. And so the question is, how do you get fired in a job like that? So your responsibilities are to run 4,000 or 5,000 ETL jobs a day to feed a global kind of analytics environment that's being sold, right? So the data is driving products and services worth hundreds of millions, something like this, about 150 million. And in that environment, there's a lot of moving parts and pieces, an incredible number of things happening. And I'm going to go through some of those details. But in this kind of environment, a single file getting lost in the shuffle can mean the difference between getting fired or keeping your job. Okay. So as an example, not a live use case to protect the innocent, let's imagine that a currency file that you use in finance to transfer all of your kind of transactions that are done in local currency like pounds, say, into euros. This file is really critical, and everyone uses this one file, and it rifles through your organization, having impacts in a kind of large DAG-shaped impact. And if getting that wrong happens, what ends up happening is that error is then propagated through a number of different solutions and systems, and this contagion occurs. Okay, so someone arrives at your office and starts shouting. They say, "Look, all of our stuff's wrong. Customers aren't paying us." You then say, "So what do you want me to actually do about it?" "We want you to fix it." Great. You do realize that people are unhappy. There's probably a lot of other customers who haven't noticed yet, right? So the financial risk of not fixing this is actually much bigger than the stuff that has happened already. I probably need a budget to fix this. You know, and then you start to talk about, in retrospect, so what was it that went wrong? And then you discover that an FTP site, the login credentials have expired because there's certificates or something like this. And that one day, that file didn't arrive. But the data engineer on the team, he set it up to pick the last file in the list that's sitting in this log of files. And so what happens is, for about a month, the old file's picked up and shuffled along. And no one notices for a month. And then the financial reporting goes up to the board. And then everyone's, buying this data, making decisions. And then you realize at some point, some canny accountant kind of looks at it and says, well, no, we had Brexit. These currencies are moving all over the place. And these numbers haven't changed. And that's when you realize, oh my God, I think I broke everything, right? So hundreds of dashboards and reports could potentially be affected by this. So this is the backdrop, the thing that really catalyzed the need for this solution and how we got started. So let's talk about what the problem is. I'm calling this problem the many hands problem. So in such a vast estate, you ask everyone, how long did it take to create this estate? And then people say to you, well, it took us 10 years. We've had a team of about 50 for about 10 years. Different people coming and going. And every single job that's set up, it's like a fingerprint, it's like a handprint. You can actually almost tell who wrote this job, right? You can look at the code. These are really specific ways of working that people have. And when you have hundreds and hundreds and hundreds of jobs running every day, it kind of looks like the picture at the top right. There's this huge amount of complexity that's introduced by loosely connected data pipelines And each data pipeline has this little oddball thing, like that one guy who didn't check that it was today's file, right? So you have this kind of massive connectivity issue, and it's very, very complex. And I think Google's published a paper some years ago I read, and they mentioned the risk in data science of entanglement and the entanglement of data science models. But I actually think that the entanglement problem is much deeper. I think it runs through all of our data engineering and science, and that actually running a large estate in production is just really, really hard. And we've probably in this conference been hearing lots about the knowledge graph, and all that is another form of holding this huge set of data, right? But collecting that data and rifling along and marshaling it into the place where you can do the work is actually most of the problem, right? Using a database is a joy. Loading a database with 1,800 sources sitting in 5,000 feeds and getting that right every single day so you don't get fired, like that's a chore. So this is what this talk is about. And when you're in the graph game, you start thinking, well, how does that play? How can we fix things with that kind of a view? So how complex is this problem in a large enterprise where most things have been built before you got there? So when you investigate sort of the sources of the problems and what you need to do to fix everything, you discover that there's probably hundreds of production databases that you need to source your data from. So in one place I worked, there was 112 SAP systems, right? That's a lot. It's a global company. They have one per country. Kind of seemed right for them, okay? You then start to talk to them about call centers. Well, that's organized by language group. So now you have about 40 of those. And so you start to talk to everybody about what they have and what you need to source, and it's getting rapidly complicated. People have said to me, oh, there's this great tool and it uses Airflow, we'll use that. Okay, well, 10 years ago, no one built anything with Airflow. 10 years ago, I'm sitting on something like 1,000 SSIS jobs, sitting baked on some kind of out-of-memory server that's running SQL Server. It's probably running an out of support version of SQL Server. And so I have multiple orchestration tools, multiple ETL tools. I probably have seen many people with multiple Kafka instances, multiple Confluent installations. I'm seeing a whole catalog of logging tools for all sorts of purposes also in play. When I ask people about their data warehousing needs, I find out that there's actually 8 global data warehouses and many operational data warehouses in each country. So it's not really a warehouse anymore, it's just a local reporting thing. And then we go and we look at how it's being used, and there's maybe thousands of reports and dashboards and many more thousand products and services that take this information, okay? Never mind just the normal stuff like lots of data centers, lots of clouds, lots of networking issues, and probably every data scientist or every data science team has their own sandbox, and this stuff is where the prototypes are coming in, and your job is to productionize it, right? So there's this hugely complex, vast estate, and getting your hands around this problem and fixing it is really difficult. Some of the things that I needed to do, that I struggled to do in this kind of environment, they seem quite simple, like how do we manage simple change? So somebody would like to retire this solution and replace it with that one. So what breaks? It's hard to reason about this when you don't have a graph there to interrogate. Quality of service, as I talked about, but also just delivering service oversight, justifying the need to pay 50 engineers, right, when half of them are remediating broken feeds. It's hard, right, if you can't explain that story. So there's a whole pile of further things going on around what I call ground truth. So another thing that's surfacing, and I've been in data 25 years, and I did this enterprise data architecture role maybe 10 years ago. And back then, there was this view a lot of people had that enterprise data architecture was a top-down investment, right? We would then structure things into logical boxes, and everybody would shuffle into their box, and we'd have hard constraints between things. And we'd have these interfaces, and it was a top-down view, and eventually someone would decide that data architecture was something that needed to be documented, and they'd build a giant train set of your company. And this train set would rapidly be built, described, used to do all kinds of planning, and within about a month it's out of date, and about a year later it's useless, and this huge effort has gone in to building this. So this top-down approach, it was really hated by myself and a lot of other engineering-led people. And now it's not really done anymore. It's deeply unpopular. But the problem is that actually their goal of building this artifact that we can interrogate was a good goal. It was just not a top-down goal that was feasible. So the question then became, for me, well, I still need some of the stuff I used to have, but I need to generate this information in a new way that's bottom up. So I want to just size this problem a little more in terms of how where we need to fix things and how we go about doing it. So I'll just show you some examples just to give you an illustration of real complexity. So in one place, like that 10 years ago kind of view, I'm like drawing up all of the systems and all of the information that flows between them. Now this is a logical view, meaning that actually any one of those highlighted boxes that are in the little bubbles, there could be up to like 40 of them as they stepped and repeated across countries, right? So this is a summarized view. And there's a huge amount of complexity, and it hasn't come up too well on this small screen, but there's something in the magnitude of sort of over 150 logical systems and several hundred real flows. And because they're logical, when you look at the physical ones, there's probably many thousand. And that environment involved batch messaging and streaming. In another case with another large global company, the one with the 112 SAP systems, I actually was asked to summarize the entire data estate so we could understand how we could use all these assets, right, and leverage them using things like AI. Okay, so about 6 months later, we end up with this diagram, and it kind of shows us that there are about 14 major data subject areas of information, and at the really, even at just most conceptual level, that there is in fact there something about 410 core entities within their subjects. Now, this is just the management view that I use to go upwards to talk to the boss, right? Actually, that looks like a great big entity relationship diagram with all kinds of complex notation and constraints like many-to-many, one-to-many, for example, across this picture. So any one of these could be connected to any other one of these, right? So it's actually a really complicated view, and this is also the canonical view of the organization. So any one of those data points could come from maybe 50 to 80 systems, right? So if this was your Grakn knowledge graph, and we summarized the ontology into a view like this, and it was as complicated as that, top tip from me, don't go show someone a level 4 complex entity relationship diagram. Don't show that upwards in a big enterprise because it'll just scare everybody. This is how you draw an enterprise data model at that size. So if you have to draw your knowledge graph, I would really suggest that you theme it up into subjects and that you produce some kind of viz like this. If we move on, in the olden days of data reporting and analytics, we used to see that people had a star schema. And actually, it's very interesting that when you look at the way we pipeline, design things using pipelines today, for real-time streaming, for example, but also just even in batch cases, this diagram has also come up a little bit wonky on the screen. But what I wanted just to say is that when you look at it, you discover that these pipelines are built at the use case level, and they take in dimensions, and they create facts from raw data, and they then produce something. And if you map them all up like small graphs, so every use case is its own little graph of a fact and sort of dimensions, as you additively start to accumulate them and study them as a whole and all the connections, you notice right away, and this is a Nito plot, I think, dot, you can see that it pulls the most highly connected dimensions into the center, building a bullseye. So the currency conversion file sits at the middle of this bullseye because everyone uses it as part of their flow. Now, when you're managing your estate and you go to GCP or AWS and you say, list all the things in my Redshift or list all my things in my Bigtable, you don't get a sense that there's this one that's like burning hot, the key and critical table that'll get you fired. You just see a big long catalog, okay? So in this view, what we see from the network connections between all these things is that in blue are the fact pipelines that are most cases are streaming now. And along the outside, these are these local, what they call side inputs So these are lookups, dimensions for doing recoding, their dictionaries, and their sort of tagging systems. And so what you end up with is this complex set of peripheral dimensions that are only locally impacting. So if one of those were to break, it's a very low impact failure. However, if something in the middle breaks, you could be looking at sort of a contagion event. The one I faced was similar. So this is also very complicated. When we put the three together, I mean, you guys are already at a graph conference, so I don't really think I need to ask you, but do you see a pattern here, right? This is all graph data, all of it. This is our enterprise data architecture from old that we still really need, but we can't afford. And it's all graph shaped. And without it, we have failures and contagions that we can't really mitigate. And we have risks that we don't understand. And we can't plan change. And we can't respond to events in a timely fashion. And so you can see right away where I'm going with this, I think. Okay. Last thing I would just say, the reason why I need a singular graph model, right, to understand all of these connections and the pipelines as they work in real time is because I'm managing this mixed estate of legacy and new stuff in the cloud together. So I need to be able to just like, if you get to be a director of a data company and someone says, hey, could you just give me a quick management summary, right? What's your team done this week that's valuable? Well, I ran 4,693 data feeds. All right, so which customers care? What? Yeah, okay, so tie it to the business value so I know that I need your team. Because, so there's this view that we need to have commercial line of sight. And this combined service along the top, even if you can do it with the new stuff, which is much easier, it's very hard to pull it together from across both sides. So what is the idea? First, the idea is to lay down some framing architecture to say, look, what is it we're trying to build in this new environment? And how can we actually just partition it up into consumable pieces? So this is basically the architecture of a large data organization. I've actually seen 5 or 6 big organizations like that, and they're roughly organized the same way. And this kind of illustrates, if that said in the middle there, shared data platform, brackets, knowledge graph, it wouldn't be that much different in a knowledge graph environment. Around that knowledge graph, you still need these additional pieces to make it all work. So what are those pieces, right? So you have loads of internal source systems, as we've sort of seen in those diagrams. We have a need for data governance and managing policies around the usage of data and PII and GDPR type concerns. We are buying data, and there's all the contractual arrangements about the usage of that data and deriving information from it and using it for particular purposes. And all of that is kind of being organized as a precursor to then acquisition functions that actually drag the data across networks and perform that kind of ingestion service. Along the bottom, then, you have a data quality piece that needs to be put in so that you can vet all this information and that you can bounce things that aren't working properly or are drifting out of sync. An example is, I say to people, the pipes are all working, but the color of the water is now brown. Okay, so we need to really get a handle on data quality in a big way. And if you're feeding a knowledge graph and the metrics and the types of things that you're putting in, if they're aggregated in any way and they're coming from bad input numbers, you can skew whole things and it's hard to back out. So this upfront quality piece is really important. Service monitoring, as I said, it's a really important part of this story. If you can't monitor and report on your own team, then no one trusts you to deliver the deal, right? So if you're trying to build a knowledge graph and you can't even monitor what your guys are doing or explain why they're doing what they're doing, you're probably not long in the game. On the right-hand side, obviously, there's a lot of things going on around professional services and digital services and products. And typically there, what I see is there's a vast estate, and it's organized by squads working in agile kind of methodologies. And these individual small squads are building a huge range of products and services that do things like BI, UI, and AI. And so this serving area at the far right of our kind of little hexagon there, it's actually turning our raw data that we hold in this kind of structure into consumable APIs that contribute to the delivery of value and then revenue. So the question is, if something breaks along the left through the middle, and then someone on the right finds out, that's like way too late, okay? But that's where everyone finds out a mistake has happened. So it's very costly to remediate these things. Let's just focus on this. So what does that look like in the middle? If I just zoom in, I have a generic architecture I've been putting in for most people, and it looks like there's a bunch of interfaces along the top, things like acquire, administer, query, and consume. These are those value-adding APIs on the right, and these are these acquisition pipelines on the left. So all of the middle piece there, the pipelines and stores, we now have a pipeline-centric architecture, and this is so we can accommodate both real-time and batch. And we would go through and build sort of directed-acyclic graphs for ingestion and refine. And these are processes to both acquire and stage the data, and then to refine it, do the quality controls, maybe amend data or quarantine it. And then finally, when it's ready to go, then there's a box there that's called store, where you actually would then write out the files to some kind of a knowledge graph or to whatever data structure you're using. And in some cases, there's specialist data structures required that are not knowledge graphs, right? So it's just some, I have a list there, but you can see that there's all kinds of things that we might hold in a data lake, including graph databases. And I put Grakn in along the side because I actually think it's a key component as part of the platform piece, in addition to whatever graph. So for different NFRs, like non-functional requirements, we might use a different graph database. It might just not warrant an install of some scalable technology, right? On the right-hand side are your consumers, and they've got pipelines that do transformations and solution logic, and that's all of those reporting type things, or those are all those secondary functions to generate the value, maybe doing science, for example, applying machine learning. So this is kind of the landscape we're in, and you can see right away that the failures don't happen when data is at rest, right? The failures happen when data is in motion. So we have to really examine our pipelines, and we have acquisition pipelines and consumer pipelines. And so what I proposed in my complex job where everybody was upset about quality, that actually we would do a couple things. One, we would implement a common logging framework. And this common logging framework would be tied to pipeline, right? So what we would have is every pipeline along the bottom there, we would industrialize it into our stages, and then we would inject into those pipelines a small bit of code, a bit like you might have in a website for Google Analytics. It's a small piece of code that just writes a message, okay, and it says, I'm pipeline 460, and I started. It's a really simple message, right? And then you go through, and each of the acquisition steps, I grab this file from this source, I grab that file from that source, I applied a file schema or input layout to this HDFS directory, whatever all those things are on the left. You start to see these little dots, and those dots are all the task level events. And in something like an Airflow, you can set out right away your flows, but you could actually set up a flow for each of the white boxes, and then you can have a pipeline event calling those in a larger kind of pipeline, so that you can nest these things a little bit for reusability purposes. And all of them will instrument and throw messages. So a message broker is a nice way of me saying Kafka without saying Kafka. Okay, so we would pass this stuff into a real-time messaging hub, ideally in a format like Avro, so that we could parse this information cleanly, and we would have it across our entire estate. Now, these pipelines at the bottom, you can do this with SSIS, right, from Microsoft. You can do this with BODS, which is the tool that is the ETL tool of choice for SAP. You can do this with Informatica, right? Ab initio, SortSync. There's any number of tools that are open source as well, where you can build a pipeline. In fact, you don't need to even use ETL tools to put these logs in. You can find all the stored procedures in all your databases, and you can actually instrument those calls as well. And actually, there's a large number of things happening in databases where people use stored procedures and triggers to get things done, and where people are actually using a scheduler to kick off something like a script that then calls these stored procedures. So it's actually an architecture that is heterogeneous and it's not tied to any technology. And the idea there is that all of it's getting instrumented. Now, when it finally lands, it lands in something called the event store, which is just a really big fancy name for it. Probably stays in Kafka as a giant list. But you could actually write it out to physical tables. You could put it in Delta Lake. You could stick it into Redshift, whatever you want, right? You could store that event data, but it's basically a large list, and you need to be able to write to it fast. And then from that, what we have just to the left of that is a graph ops, so data ops graph store. So what we need to do then is we need to select the key juicy bits of information out of this event log, and then we need to do things with it. So one thing we might do is we might go and query a particular process gets a name and address file every single day from marketing. And we want to know, is the address quality dipping? So we're going to just count the number of postcodes in each file and just make sure that that percentage is above 80%. And if it dips below, we're going to do something, okay? So simple rules. But we can query all of those things in the event store, which would include the outputs of data quality checks. And we could then summarize those into facts, right? Aggregate facts, which we could rifle along into our ops graph store. So the idea is the graph store is not just at the lowest level of granularity, but we can actually, on this large data set, apply algorithms, propensity scores, and we can do other types of analytics on a batch OLAP basis very quickly there, and then stash the results into the graph. So the idea there is the graph would be fairly meaningless if it was always at the grain of one particular pipeline. Sorry? So the idea with this graph, it would be fairly meaningless if it wasn't connected to things. So the way that we've been connecting them in our solution is we've been registering all of our stuff. The registry information, we turned the process for publishing and turning pipelines into industrial processes. We had a small step that said to developers, to get to production, you need to register your solution before it'll run, okay? So everyone registered their stuff, and a registration, so the general rule is everything in life that needs managing or wants managing gets numbered. Everyone's got a driver's license, passport number, your car's got a license number, so if it wants managing, it needs numbering. So the idea is that we have a registry. Now this registry is full of metadata, and I'm going to show you a little bit about what we put in it. But the idea then is that when you throw the messages, you can throw a nice type message, put the keys in, and you can reference the data you picked up with its referenced registration number, as well as the pipeline itself can throw its registration numbers. And if there's nesting, as I've shown here, or other complex ways of calling these pipes, you can also have timers that are throwing these keys on real-time streams to check on drift. You can actually build up a graph store there. And the benefit of this is that eventually we end up with a really nice data model being populated about our estate. All the events are going in, and we can actually then start running some advanced graph analytics on that to find out what's going on and to monitor the situation. So we're calling this thing on the left side there the RunGraph. It's a graph of everything that ran in a heterogeneous estate that might involve 40, 50 data teams. It's across the world, it can be global, but we've got all of it in, and we can actually, between this run log and this run graph, we can actually interrogate and produce proper analytics. So it required two things. So when the boss says, well, how much is this all going to cost? This sounds crazy, a knowledge graph of ops, right? I couldn't even sell a knowledge graph for the real stuff. I'm trying to get this message out, right? And so it just sounds like new money. So I said, well, actually, it's really simple. We just need a very simple registration tool, and it's agnostic to any of your technology choices. And we need an instrumentation tool, and that's also agnostic to your choices, so that it's working across all of the legacy and real-time and, say, cloud-based infrastructures that you put in. And then all of a sudden, these kind of benefits start to light up. Like we can register any pipeline on our estate, irrespective of the legacy tool it runs in. We can retrofit our estate. We can then build up these complex enterprise architecture views that we never really were able to maintain in the past. And this would allow us to monitor the schedules so that we could rebuild them. We can also look and see what normal behaviors look like. And we can gauge a baseline of what normal flows and behaviors look like, from which we can then judge that this thing may or may not be working well. And we can use things like Grakn ML, perhaps, to study failures and if there's contagions on the failures, right? To see if we can do predictive analytics from the rest of our state. Again, there's a number of other benefits to do with data lineage, but the key one there is to do impact analysis. And so if you have 40, 50 things breaking every day and you have a large team fixing them, the key question is, are they doing the right stuff? So when you have a whole pile of JIRA tickets to look at, how do you sort and rank it so that you work on the one that has the most business value? Okay, so the $1 million failure that gets you fired, it's at the top of the list because you can see right away it affects all of your consumer systems. So again, just to summarize that, is a combined ops console for a combined service that is sort of heterogeneously created from legacy and new pipelines. So just a note about the registration, and also just a general note. I build these systems on a bespoke basis for clients, and it's always behind some proprietary firewall, right? So I can't, like, with NDAs and so forth, I can't come and say, hey, here's my Grakn kind of code and so on. We can talk about this general model that I put together outside of the implementations I built. So we had a much more simple implementation when we put it together, and that is really too small. So I'm going to see if I can zoom in on that just while you guys are here. See if I can. Maybe, is that a bit better? Maybe it's a bit better. So I can read off some of the key things there. In fact, if I just go back to presentation mode, I will summarize that for you. Okay, there's 4 big summaries there. There's a data model that describes data sets, and there's a relational set of things there. And if we just go back up, I'll read them to you. There's a tagging system to get those hierarchies in place to build those sunburst diagrams. So I can see a subject, a data set is a part of a conceptual entity, and then there's a physical instantiation of that data. So I have this kind of triplet. Data sets are given some kind of universal resource identifier, some URI. So there's an addressability question. So I need an addressable set of data. If you just use only S3, for example, everything's addressable and you have like a tag. But when you go to legacy, plus different environments, plus all kinds of other ways to generate data like views on databases, you need some way to understand your addressability concerns. And there's some kind of a scheme for URIs. Here in this instance, I've marked it off, but I think actually in reality, I think what we did was a hashing of the underlying data from the connection strings that we used, and then like the SQL generated. We interrogated our flows, and we actually we had different approaches to this. Other things going on, we have policies. So if you have a feed of data and you have a data set, and one of those is called credit card numbers, there's going to be a policy for what you can do with it and how it's distributed and how it's consumed. So at this level of the data set and the model for the metadata, we actually put policy information, and that way we could check all the way through our pipelines whether we were adhering to policies. But in actual fact, it's not just GDPR policies, there's also data retention policies, right? There's also things like data quality policies. And once we have metadata about the data we hold, and we have policy information that we can stitch together in complex Grakn queries, we can now identify all of our data assets that need to maybe be queued up for a deletion, for example, for retention reasons. So actually, this is a very sophisticated analytics environment now, where I actually have a mechanism to really quickly say, for this particular data supplier, I bought the data, and they said I can't keep it, and they'll stop providing me with data if I don't, really take that retention policy seriously. In other cases, it might just be data you get off the web, right? It might be not as serious. So you can actually tailor all of the analytics you do and the graph interrogations to suit your needs, to identify actions to take, to both curate and do housekeeping on your ultimately your large data sets. Also, there we have a whole mechanism for describing feeds, including things like schedules. So a really hard error to spot is that a file didn't arrive. It's really easy to spot things that are corrupt when they come, but if you don't have expectations about when things should happen, then it's really difficult to see the missing. So this system allowed us to then put in the expectations and then to understand whether we were finding things that were actually just missing. Around jobs, this is all around the submission process for jobs and the logging. And so that's where we keep our large log. And the four of those together create kind of a metadata system plus the job log and tracking that allowed us to create this, solution. So even simple use cases in terms of Grakn queries would be very, very useful for many people, right? On a failure, can I find all the descendants? I want to remediate based on impact. Actually, I'd also like to find all the ancestors because I like to apply pressure to the person who messed up the file and then gave it to me. Okay, so you're running some SAP system in Bulgaria, and I know that you don't think there's a change control process, and you've just like changed everything, and actually now everything I have for Europe is broken, right? So I need a way to go back to senior leadership and to say, look at the impact this behavior is having on our consumers, and that commercial line of sight now means that you have significant revenues at risk because of this one action, right? So you need to go down and give someone a kicking, right? So that's the general conversation. But you can't really have this in an evidence-led way if you have no evidence. So this is all about an evidence-led discussion. Plan changes as well. A lot of people come and ask me, hey, can I swap this? And they think it's very simple. And then I actually discover that there's a huge amount of retesting to do and risk involved in those changes. And we just need to set the expectations properly. Again, just a banner to say that this RunGraph analytics improves your AI, BI, and UI as a general piece because it adds the quality control and trust. And that is the end of my talk. I kind of raced through it some bit early. I wonder